This is Queenie, and next up we will be talking about some terms and definitions. The average outgoing quality is the average quality level of an outgoing lot for a given value of incoming lot quantity. The average outgoing quality represents the relationship between the quality of incoming and outgoing material, assuming that 100% of inspected rejected lots replace all defects with good units. The defective items is either removed or replaced. If all lots come in with a defect level of exactly P and a given probability of accepting a lot, and a sample size denoted by lowercase n and a lot size denoted by capital N, then we will have the following formula for the average outgoing quality. The acceptable quality level is a percent defective that is the baseline requirement for the quality of the producer's product. The producer will typically like to design a sampling plan such that there is a high probability of accepting a lot that has a defect level less than or equal to the acceptable quality level. The average outgoing quality level is the maximum percent defective in an outgoing lot, also known as average outgoing quality limit. The average outgoing quality is dependent on the incoming quality, the probability that the lot will be accepted, and the sample and lot sizes. When incoming quality is very good, outgoing quality is also very good. When incoming quality is very bad, the entire lot is rejected. Therefore, the outgoing quality is also very good because the lot will be rejected and the bad parts won't get through. When incoming quality is not very good or not very bad, the outgoing quality gets worse and the percent defective in the outgoing level approaches a maximum known as the average outgoing quality limit. Next, we have the average total inspection. When rejected lots are 100% inspected, it is easy to calculate the average total inspection if lots come consistently with the defect level of P. For a sampling plan, NC, with a probability PA of accepting a lot and a defect level P, and we have the sample size denoted by lowercase n and a lot size is denoted by capital N, then we will have the following formula for the average total inspection given. Next, we have the average sample number. For a single sampling plan, we know each and every lot has a sample of size n taken and inspected or tested. For double, multiple, and sequential plans, the amount of sampling varies depending on the number of defects observed. For any given double, multiple, or sequential plan, a long-term average sample number can be calculated assuming all lots come in with a defect level of P. A plot of the average sample number versus the incoming defect level P describes the sampling efficiency of a given lot. Next, we have the lot tolerance percentage defective. The lot tolerance percent defective is a designated high defect level that will be unacceptable to the customer. The consumer would like the sampling plan to have a low probability of accepting a lot with a defect level as high as the lot tolerance percent defective. And so we have the type 1 error, and is also known as the producer's risk. This is the probability for a given NC sampling plan of rejecting a lot that has a defect level equal to the average quality level. The producer suffers when this occurs because a lot with acceptable quality was rejected. The symbol alpha is commonly used for the type 1 error and has typical values that ranges from 0.1 to 0.01. And for type 2 error is also known as consumer's risk. This is the probability for a given NC sampling plan of accepting a lot with the defect level equal to the LTPD. The consumer suffers when this occurs because a lot with unacceptable quality was accepted. The symbol beta is commonly used for type 2 error, and typical values range from 0.2 to 0.01. And this concludes our lecture on acceptance